We're going to try our hand at drawing a basic register. So this that's given here, that's just like an example of, hey, this is a register. We're going to do a similar one. The one that's on here holds its value or loads a new value in parallel. We want to have one that holds its value or shifts right, and it has serial input, serial in, and serial output, serial out. So you can have your registers either that, like the last one comes back around, inputs to the first one, or you can have an input and an output. So we'll have 3 flip-flops. And we only have 2 choices, so we just need a 2-to-1 multiplexer. S, 0, 1, 0, 1, 0, 1, and that will tell us whether we either hold the value or get an input or output. We'll put a clock in. We're going to have some variable that's going to tell us which we're going to do. So I'll call this variable Bob. Does it give me? No. So Bob is in charge of telling the register whether it's going to hold its value or shift right. And we're going to use D flip-flops. And let's have that if it's 0, it holds its value. Okay, so if it's going to hold its value, that means it's going to have the same value it had before. So you want it, like I said, I'm terrible at drawing these. If it's 0, you want it just its output to become its input. And I should have all of these multiplexers, their output is going into the flip-flop. Now, on the other hand, if the input is 1, we're going to want it to shift right. And so we want the value, if I call this 2, 1, 0, we want the value from 2 to go to 1, and it'll do it by going into the 1 input of the multiplexer. And we want the value from 1 to go to 0. But then we also need to have an output. So that'll be this serial output. And we need to have something going into the first one, and so that'll be the serial input. Is that good? Okay, now last. This is a typical kind of problem from your professor with lots of different choices. So this is one that's from your homework, but one that he worked out. But I think it will help you with the one that you have to do to turn in. So it's still just a register. It's just you have 8 different possibilities of what can go on rather than just 2. So on the one we just did, there were just 2 possibilities. On these, there are going to be 8. So we have to have an 8 input multiplexer. Well, for each flip-flop, well, whenever you have a register, for each flip-flop, you're going to have a multiplexer that tells it what to do. And so for each of our flip-flops, we're going to have an 8 input multiplexer. So it's just 3 outputs, X, Y, Z. So we just need, since there's 3 outputs, we just need 3 flip-flops. That part's easy. I'm not going to draw the clock. You can draw the clock. I just don't need any extra lines because I can't deal with extra lines. Okay. Now we'll need an 8 to 1 multiplexer for each one of these. And I will go ahead and number these 0 through 7. And if we are going to have 8 different possibilities, then that means that we have to have 3 bits coming into these. So the one we just did, there are just 2 possibilities. We just needed 1 bit. We just needed 1 signal. I think I called it Bob. Here we'll need 3, and we'll label those S0, S1, and S2. And your output from your multiplexer is always what goes into your flip-flop. And so I'm just going to draw it like this. Now we need 3 wires to represent S0, S1, and S2. S0, S1, and S2. And just like in our example from before, that these signals, these selects, are going into all of our multiplexers. At least I got these lines straight. And so S0 goes into S0 for each one of these. S1 goes into S1. And S2 goes into S2. And now I know, because I looked ahead, that it will be useful for us to be able to easily access the outputs of each of these. Not surprisingly, just like before, the output for one can be the input for the other. But since we've got so much stuff going on, let's make it easy for us to find these outputs. So this one is, well, I might want to put I might need I'm probably going to need a Q bar on each of these. But I'm still going to label this first one X, the second one Y, and the third one Z. Okay, so this purple wire, that has the output for X. The orange wire has the output for Y. And the pink wire will have the output for Z. And again, I'm just doing this for convenience so that we'll have them when we need them. Okay, so y'all have this in front of you? Okay. So it says for 0, 0, 0, which is the binary for 0, the register outputs are unchanged. So that means X needs to go into X, Y needs to go into Y, and Z needs to go into Z. And that's into 0. For 0, 0, 1, we shift right by 1 bit, and a bit enters on LN. So we're shifting right, and so that means that X goes to Y, Y goes to Z, and LN goes to X. So X goes to Y, Y goes to Z, and we have a new variable, LN, that will go input there. For 0, 1, 0, which is 2, that's a shift left. So Z will go to Y, Y will go to X, and bit enters on Rn. So I'll have a variable Rn that's going into 2, and then Z goes to Y, and Y goes to X. 0, 1, 1, which is 3, says load A to X, B to Y, and C to Z. So just a new variable. I'll write it down here. A goes to X, B goes to Y, and C goes to Z. So 1, 0, 0, which is 4, says complement outputs X, Y, and Z. So we could put, I think I'm actually going to do this slightly differently than he did. Yeah. So he drew wires coming from the Q bar from the D flip-flops, which is the most economical way to do it, but my drawing's already messy enough that I'm just going to put some a little NOT gate in here. So X NOT goes to X, Y NOT goes to Y, and Z NOT goes to Z. Okay, so now our next thing is to rotate. So rotate is different from shift. When you shift, you have to shift in and shift out. When you rotate, the one at the end goes back to the one at the beginning. So rotate to the right. Okay, so X goes to Y, Y goes to Z, and Z goes to X. So I do not have a wire drawn all the way over there. So I'm just going to stick one on here, no over there. Now we rotate left by 1 bit. So Z goes to Y. Y goes to X. And X goes to Z. And then 1, 1, 1 is to clear the outputs, make them all equal to 0. So you just have a 0. And put that in there. And I am always very glad that I don't have to grade these things. So any questions on that? It's the same basic idea as the simpler ones, it's just got more to it. And so I find that the key is do it once and then copy it and make it neater.